Swayam Prabha. Digital India. Educated India.
Welcome to this Swayam NPTEL course on building energy systems and auditing. So, first of all, let me thank all of you to join for this particular course, which is the first time it is going to be offered in the NPTEL platform. So, we have 8 modules. It is the first module which includes the general introduction of the introduction and building physics, and we will actually in the very first lecture we will just do some kind of the introduction to this particular course in this lecture. So, in that first of all let us first introduced with this particular lecture before we go to some other the details. I am Dr. Shankhapratim Bhattacharya. I am a associate professor in the Department of Architecture and Regional Planning. I am here in IIT Kharagpur in last 13 years or so, and almost 12 years I am teaching this particular subject to the undergraduate architecture course. And in our IIT Kharagpur we have a system that some courses it is a kind of a open kind of, it is a core course for the architecture, but it can be opt as a depth elective for the other disciplines also. So, many students from the other department, mostly from civil engineering and mechanical engineering, and opt this particular course as their the depth breadth elective or those kind of the additional courses. So, that actually initiate a thinking from my side that why don't I start this particular course as a NPTEL platform, that the nation will be benefited or maybe the students of our country can be benefited. So, I have designed this particular course, and we will start this particular course mostly from the lecture number 2, but today let us have some kind of overall understanding. So, as we all know that almost 80% of the time we will spend inside the building, maybe in your institute you are spending, your home, and then maybe you go to a stadium, you play some, so that may be indoor stadium, or so you may go to some mall for purchase something. So, almost 80% of the time we all are spending inside the building. So, and because of those kind of some of the activities inside the building, it requires some kind of energy, and mostly it is due to the activity, and the second one is due to some kind of the thermal comfort or so, thermal comfort, acoustical comfort, or maybe comfort from the visual comfort, like I need some kind of illumination here to read those lecture notes and whatever. So, those required the comfort requirement and the activity requirement. Activity requirement, you may say my mother will cook something for me for my lunch or for my dinner. So, that is the activity, that activity requires some kind of energy. You require some kind of a LPG or that kind of a the fuel to prepare the breakfast, dinner, all those things. So, everywhere if you see for the activities, any kind of activities, it requires some kind of energy. Even sometimes I may say that sometimes in the maybe in the Facebook or some social media, you put some like that yes, this you like this photograph or something like that. Even that particular activity is required some kind of energy, even maybe a very small amount of footprint, but still it is required some kind of energy. You have to actually do some kind of the you have to activate your laptop, or maybe you have to actually charge your cell phone to make that kind of a activity, that I give a like to my friend's photograph or something like that. That particular byte has to be stored in some space, some kind of the server for long time. 10 years back, if you have given somebody something like or some comment, still it is there. So, it is storing that particular byte is storing that kind of a storing somewhere there. So, each and every activity, any kind of activity, you can say that each and every activity is required some kind of energy. So, this particular energy requirement day by day it is increasing in the urban areas, also in the rural areas, because we are increasing the degree of the electrification, and almost 99%, 95 to 98% of the India is now electrified. I mean, electrification has been done. So, people are getting benefit out of it. Electrification, the energy spending is, if it is more, on the other hand, the economy will definitely going to boost. So, that is another thing. Economy, if you want to boost, so you have to have the energy supply has to be more. Level of urbanization is increased in our country. So, you require more amount of energy for any purpose, may not be in the building, but must be from other transportation sector, industrial sector and all. The amount of building area per capita is also going to increase. We still has some kind of a housing demand. So, in future lot of housing is going to come. Government of India has a lot of effort, and they are going to give in lot of areas, want to penetrate even in the rural area, peri-urban area, to build more and good and efficient house. So, that is another the potential areas to where energy is required. The prevalent climate, and we know that there is a climate change, and there is a temperature is increasing. There is a differential type of the problems that occurring, and for that, to encounter that one, we require more energy. The national local policies promote efficiency. We see that there are some national policies are there, sometimes there are some kind of the state government also have some kind of policy that will actually going to promote some kind of a some type of energy, maybe the solar energy or something like that, or maybe the energy efficiencies also. So, more or less there is a the things are actually moving around the use of energy and the demand of energies and all. So, that is why this particular course is very important for the architects and the budding engineers, from mostly who are the building engineers, I must say civil engineers and the building engineers, architects, to know about something on that. So, first of all, why the save energy? It reduce the rate of natural resource dilutions and all those kind of thing. It is going to reduce the pollutions, it is going to reduce the greenhouse gas emissions. Fossil fuels are not clean energy sources also. It will actually going to balance the environment and the ecosystems. So, it is all known to everybody. It will control the climate change, it will going to save our money, because finally and also earth as a whole, finally if I want to purchase anything, you have to purchase energy also, for more energy. So, you have to purchase more, you have to spend more. So, now let us come back little bit from the energy to the sequence of courses in architecture. Most of the I am focusing on architecture, because there is a chain of subject in the architecture where we find this particular smooth chain, and here where I am, where this particular courses, let us see. The first of all, what we understand, what we teach student, and when I was also a student like you, I was first taught on building physics, which was a one kind of a chapter, or maybe some small concept in our climatology. So, the second one is the climate responsive, the architecture or climatology, we may say. So, building physics is kind of embedded into the climatology course, and these two become a kind of a course, climate responsive architecture or whatever. So, in our time, I have graduated in 90s, long back. So, our time that was the finish, there is no more course on this particular arena. So, gradually in demand, or when you understand that yes, there is a demand of the energy, 2009 first ECBC code was first prevail in India, and then there was a kind of a pressure that you teach energy efficient building design and all those kind of a thing. So, beforehand already it was started in the particular arena that we start some kind of a course called the energy efficient building design, which actually coming down line of the climate responsive, which is probably the focus of my this particular NPTEL course. The name is different, building energy systems and auditing. Why this name was there, you will understand if you go through this particular course. It is a building systems which actually required or consume some kind of energy, and definitely there is a audit required, because you should know that how much you are gained or how much you are fall back or something like that by, and that particular thing is required. So, the energy efficient design feature, yes, some part of it we definitely covered in the climate responsive one, but mostly the codes and the modern codes and the all those things, fundamental things has to be look into in different perspective. So, this is the particular course which I am going to cover in this particular lecture, in this particular the NPTEL course. After that it moves towards the green energy, green architecture also. This course is also available nowadays as a kind, sometimes is as a core, sometimes is an elective course also. And green architecture is all about the not only the energy, it is also about the soil, it is also about the site, it is also about the air, it is also about the water, it is also about the some greeneries and all these things. So, whole, so there are IGBC, there are the TERI and the Griha rating systems and the lead India lead rating systems and also. So, that is a whole. So, it is now from the energy to the other the environmental part of it. And finally, it goes to the sustainable development. There are some courses, of course, there are still today, I mean now it is available in some of the very good institute, or it is sometimes taught by everybody, not institute dependency. I mean I know every institute that teachers are actually going to give some maybe one module minimum on the sustainable development, where I am not only thinking of the environmental part. If you see from the third one, energy, the first three is concentrated on the thermal comfort and energy, and the building design, the first one maybe the first two are maybe the building design or so, and the thermal comfort, energy. When it comes to the green, then it is environment, when it is not only the energy, it is also take care of the what I told, the water and the soil and air and everything. And when come down to finally the sustainable development, the one part is the environment, the other two part will going to open out, which is one is economy and another one is society. So, social development, economical development, environmental the protections and all those kind of thing, and that is a kind of a. So, this is the sequence of the course in architecture. So, I am exactly at the central point, the CG point, that is the energy efficient building design or so. So, in this particular lecture, how I map this particular course. So, when I see this particular course, or when you also will appreciate that if you cover this course, that my first focal point, actually I have two focal points, the second one I will write down little later. The first focal point is building life cycle energy consumption and the building energy conservation principle. So, a building in its whole life cycle, starting from the construction to the demolition, maybe around 50 to 80, maybe 100 years, it consume energy. So, I have to look into the whole life cycle. I cannot only say yes, initial 5 years or whatever, maybe that is my focus, no, or maybe only the operational energy I am going to focus, no, I have to see the building life cycle. Mostly we will consider the operational energy, but also you have to see the embodied energy and the demolition energies and all those, and we have to see the energy conservation principles. So, to do that we need to have some of the fundamentals of principles of climate responsive, the climatology, building physics and all we have to teach, we have to understand, we have to brush up, and from there we have to take it out some kind of a theoretical concept on the building energy systems or so. So, that will be implemented how in this particular concept or particular understanding we have to see, and also we have to see the practical application of the building energy estimations also, how to actually estimate the energy. See, if I do not estimate the energy, I do not know to estimate the energy, I cannot prepare my budget, and it is without leaving out all those kind of the mathematical or the numerical computation, if I want to design this course, it will be very, very flat. So, please prepare for some kind of numericals in every lectures, but those numericals are very simple numericals, and those numericals are practically implementable, these things, and those is required. Otherwise, a particular energy conservations, energy requirement, energy spending, energy generation cannot be a kind of a course, otherwise it will be very flat kind of a things are there, very theoretical will be there, and that will not going to serve any purpose. You have to have calculate the total amount of energy demand by virtue of some kind of ideas and some kind of a theory and the numericals. Okay, so, that we cannot bypass, we have to see how the through the heat gain, how heat is gaining. So, we need to know some kind of a basic heat movement, heat generations and the heat conductivity equations and all, which is not at all very complex in nature. It is very simple, addition, multiplication and maybe divisions, this and subtraction, something like that. Then the other part of it is this, there are some handbooks, there are some codes. We have the ECBC code, we have the Eco Niva Samhita code given by the Bureau of Energy Efficiency, we have NBC, we have some kind of ASHRAE guidelines, some handbook on the functional requirement of the building. So, what that code, we have to actually follow that, what they are saying that we have to follow, and then we have to judge that yes, my building is not efficient enough or my building is 50% efficient. So, those we will going to learn how to do those kind of a, and again that will going to go back to my life cycle, mostly on the basis of the embodied the operational energy. The second focus will be my energy audit and the energy retrofit. Now, we have to do the audit, otherwise I do not know the what is going to what is my present state. If I do not do the audit of my whole everyday's budget, the market, every day I am going to market to purchase some vegetables or so, I need to know, I need to have some kind of a budget, and I have to audit it from maybe yearly or whatever, that yes, I am spending much more maybe in some sector. So, I have to reduce it down. So, energy is also something like that. In various sources I am going to purchase energy. I can purchase from the electricity grid, I can actually purchase some kind of a petrol to run a particular DG means diesel generator also. I can purchase some kind of a LPG to my hotels for running for cookings and all. So, I need to know the whole amount of gamut of energy I am going to purchase, and I have to see through some kind of a audit that yes, where I am going to actually there is energy leakage also, or where actually most of the energy is unnecessary maybe, or some part of the energy unnecessary is non utilizing, or maybe they heavily utilized or something like that. So, based on that I can actually see how much I can actually go for some kind of a green energy generation. So, that is also we are going to discuss in the very last module, the solar energy generations and all. Again those everything again giving me back to the first objective as the building energy conservations or so. So, those are required. Sometimes we have to go some kind of energy retrofit. After running 10 years I may change my roof, I can go for the cool roof solutions and all those kind of thing. So, those are the energy retrofit, and that may be benefited me from the energy use from point of view. So, this is the overall map, but next I must tell you we have to go through some kind of a simple numericals with some Excel sheet. We will provide you in the Excel sheets in our forums. I have computed the numericals in all the lectures in my lecture schedules or so. If you require some kind of a some doubts and all, and maybe some kind of a other type of the help, we can actually provide those kind of a help. My only objective is that you should learn it properly. You should learn it properly, and you should actually, after this particular course successfully, you should do some kind of energy calculations and all from your own. The next important point and last point is, this particular course is prepared such a way that it will going to help you for your Griha or LEED certification course. It will going to help you, definitely it is going to help you. Some of my students told me that they have benefited out of it, number one. And I also has a kind of a focus, that is the gate architecture examination. Those who are going to write gate architecture examination in future, There are some questions coming from this domain always. So, now you can actually prepare by virtue of that and by virtue of our the assignments and all. So, in this particular course, as you know, it is a 8-week course. Each week we called as a module. The first module or first week we will go through the general introduction of the building physics. The second module, it is already there in the poster and all other in our website and all, in the NPTEL in my domain. So, the second is on the building energy systems, where we have to first week we are just going to have some kind of brush up of the building physics. Second, we have taken one of each systems. We have heating, ventilation, air conditioning, then the electrical lighting, electrical machines we will going to do, vertical transportation system we will discuss. We will discuss some amount of water supply system and low energy cooling system. The third, building heat load estimation, particularly the third and fourth, we will actually see the going to deep into the heat load calculation, because the HVAC energies are the most of the energy that actually consumed by the building, and that will going to increase the total amount of energy consumption. And what energy conservation building code said for that. So, what is the trade off method. So, those envelop the performance factors and all. So, those you have to learn. The fifth week we will go through another code, which is Eco Nivas Samhita, specially mentioned for the residential building of our country, and also we will discuss about the thermal comfort. The sixth module, again we are going back to the life cycle analysis, energy audit part, life cycle energy analysis from the embodied energy, the demolition energy and the operational energy, and some tools that we can use for the energy audit. The seventh module will go with the operational energy and the energy retrofit, how the BEE, Bureau of Energy Efficiency, are given the star rating systems to the buildings also. So, that also we will discuss. And last but not the least, the green energy and the sustainability. Mostly we will discuss about the renewable energy through PV cell, wind, biogas, those we will discuss. Again and again we will have all the lectures with some kind of a numerical computations. Do not worry, it will be very simple. If you have any difficulty, please keep in touch with us. So, in brief, again let us come back. The definition of energy. Energy is a physical term that gives us the how much work I have performed. It is kind of a thing. It is given in a sense of in SI unit, a Newton meter. Suppose there is a load of 1 Newton. If I push that by 1 meter, that is I am doing some kind of work. How much work? 1 Newton 1 meter. So, 1 Newton meter is equal to 1 joule. So, that is the unit of energy. Okay, so, that is the unit of energy, joule, and there are different type of energy sources. So, there are classification of energy we can do by primary and secondary, commercial, non-commercial, and the renewable and the non-renewable. So, just a brief about that, primary and secondary. The primary energy sources are those which is available in the nature in raw form, right. We can extraction, can do some kind of mining, we can have petrol, we can have coal, we can have natural gas, we can have nuclear power, some uranium, we can some moving water can give me some kind of energy, some biomass. So, those are the primary form. What is the secondary energy form? Secondary energy form, we did some kind of a processing and then we can actually use it. We can use through steam, we can use through heat, we use through electricity. So, if I give you some 1 liter of petrol, it is not going to be useful for you. This is a primary energy, definitely it has a calorific value, but you have to actually burn it in a machine called internal combustion machine, then only you can run your scooter or you can run your car or whatever, right. That will create some kind of a heat energies also. You can use coal for some kind of a to produce steam, and from the steam you can run some maybe some vehicle or maybe some machine. Only coal will not going to help you. Coal may have a very great calorific value, but it no one going to help you. So, primary energy has to be processed to the secondary form, and the secondary energy we can use. We can use heat, we can use steam, we can use actually electricity for our end use. So, this is the two different classification of the primary and the secondary energy. The commercial and the non-commercial energy. The commercial energies are the which is available in the market and we have to purchase with a definite price. Electricity, it is commercial energy. You have to actually pay some specific price, maybe 7 rupees per unit or something like that. Maybe it can hike after 2-3 years. Maybe petrol price, now it is almost 106 rupees or whatever. So, it may hike after maybe few months, or maybe it may there is a drop down. So, overall there is a kind of a definite price that was fixed by the government or maybe some kind of a local agency with advice to the government, of course. So, coal also there is a price of it. I mean, you cannot just have the kind of, there is the government has put some kind of a upper limit, lower limit, whatever, petroleum products, everything. So, there is a regulatory body which actually creates some kind of a price index on that. So, those are commercial energy. There are some non-commercial also which is available in the market, but not like a price tag or whatever. You can have different type of price tag, or it is depend upon the where it is available or so. Examples are firewood, examples are cattle dung, agricultural waste. Yes, those are also used as energy for cooking, for heating in our village areas or peri-urban areas or so. Few years back also it was more, now maybe gradually it is going to be reducing, but those are also some kind of a non-commercial energy where government does not have any role to play as the price, as per the price indexing or so, but that is also there in the behind the screen as a use of energies in our country or any country maybe. And then you all know that is the renewable energy and the non-renewable energy. Those are the two very distinguished sources of the energy, you may say. Non-renewable are from the fossil fuel, from the nature, and these energies are going to burn through burning or some kind of a transformation that will going to give some kind of a bad effect to the environment or so. Renewable sources, clean energy, the starts from the hydroelectricity, it can be solar, tidal, wind, or maybe bioelectricities or so. So, those are different types. Now, again let us come back to the little bit of the historical development of the energy use. Till the industrial revolutions, what happened to how the this particular energy was used as a muscular power or biomass and all. Sometimes we use some kind of a windmill or water mills or so. Please see how it is transformed within the last 150 years or so. Then what happened? In the end of the 19th century, we devised the coal and steam engine. So, gradually we shifted to that after the industrial revolution, and in the early 20th century we discover oil, and then there is a internal combustion engine, IC engine, and that is going to give a more productive things, and gradually our economy is also driving our technology and science develop a very faster rate because of that, and it's also there is a shadow of the different type of energy we are going to use, and calorific value of the energies are much higher. 1 gram of coal and 1 gram of petrol, definitely 1 gram of petrol has a much higher calorific value, much higher potential of the energies also. Then what happened afterwards? We discover natural gas, we discover nuclear fusion. So, by virtue of that, the late 20th century we can go for the nuclear power or something like that. Natural gas is used everywhere nowadays. That is also having much higher calorific value than oil, both nuclear of course and the natural gas. And what is now at present, what is happening? We are thinking of nuclear and we are thinking of the much clean energy as a renewable source of energy, biofuels, energy from the hydrogens and all. So, this is the wonderful transformation of the energy since the before the industrial revolution and today, from the muscular power to the biofuels and whatever. So, again come back to my this teaching. I am supported by my two the TA we call as the teaching assistants, Ms. Dipali and Ms. N. Kumar. They are my PhD scholar, they are doing in IIT Kharagpur, and they are helping me to design those particular PPTs and the question papers and all those kind of things. So, in your forum they will be very actively interact they will be actively interact with you, and also if required, of course, I will be there and I will definitely going to clarify your all the doubts. They will give me the doubts as a whole, and then I will going to clarify. If we need to have some kind of meetings and all online, we can also do. So, there are some kind of the academic rules or regulations we will keep in touch in through our forum. The forum should be very much actively used by you, such a way that we also very much keep in touch with you. So, any doubt, any silly doubt, there is no silly in this world. In learning, at least in this domain, there is no silly. Even if a small doubt you feel like, should I ask? Yes, you should ask this thing. We will we will definitely going to answer you. If you do not know, then I go to some other professor, ask them that what is the answer, I will come back to you and I will give you the answer. Say, I should not say that everything I know in the world. So, I will try to give my best to give you the right answer and the right clarification to you. Contact through us with the forum for any kind of subject related doubts. If required, this is very important, if required, we can also organize some kind of online Google Meet interaction. After this COVID, online meeting with people is not any issue nowadays. So, we can actually meet, we can create a kind of a meeting time, convenient time in the evening time or whatever, maybe little late also, after you come back from your the classes or maybe from your work, we can actually meet for a half an hour to 1 hour for any periodical interval for the introduction. For the Google Meet, if is required, we can definitely tell us in the forum. And for 8 modules, we have the 8 assignment has to be there, and we have designed already the 8 assignment and this particular assignment are very simple in nature, and this will be for 25 marks of each assignment, and there are 5 marks MCQ questions of 1 marks each, very simple, true false like that, fill in the blanks kind of a thing. Of course, it will be all in the computer, and there are 10 questions of MCQ and the essay numerical type with 2 marks. MCQ is out of the 4 choice, you have to write 1 choice or whatever, and essay numerical is the you have to actually solve this problem and then put the answer into a blank box. Suppose the answer is 25.7. So, you have to just type 5 decimal and then the 0.7 like that. So, that is the there will be no choice, you have to fill that. So, that is there. So, 2 marks each of that question. So, 25 marks if you go through this particular lectures, 5 lectures per week. Just go through, note down something, it will be very easy to answer those the assignment questions. Assignment questions will give you some kind of a confidence, and believe me, if you can do well in the assignment, if you definitely do well in the end semester, it will be almost the similar type of questions and all, and I hope that all of you will go for that particular assignment to the do well in the assignment. Definitely is not a big thing, you have to go through my lectures and all, and I hope everybody will going for the registration at the end of the course for the certification and write the end semester. Any point of time, if you require any kind of help from us through the Google Meet or from the forums and all, we are ready to give you that help. That is the bottom line. Kindly enroll yourself for the end semester examination and get a certificate. So, those are some of the reference, and thank you very much to join this particular course. From the lecture number 2 onwards, we will actually go into the actual course, the course content. Thank you.